Hopefully we'll get finished up this time. Sorry for all the videos. It is tough. It is tough to get time away to do these things. Um, so when we had last left, we had wired up these. We've gotten the last of our lights wired up. I don't like this. You shouldn't do yours this way. I haven't tested this exact way to see if this works, but so don't follow me. Do your own design when you're doing this. But we're gonna finish wiring all of this up, and you know, I kind of played some games with redoing stuff over here. And we're gonna have to start cutting some holes here. But now I think it's a time for us. We're almost at the end. We kind of know what stuff we got here. It's probably good to start doing some big picture stuff. I kind of, these resistors here are taking up a lot of space in here. Normally, so we need to find out where we want to put our lights that indicate this stuff, and we need to find out where we want to put our batteries here. We don't have a lot of great options. So this is where it's kind of good to start moving big stuff. So we kind of got most of our op-amp circuit fleshed out. I might kind of play some games here a little bit. I might start trying to get all this in the right location here. So I'm gonna select all of this circuit and I'm gonna make sure my grid is set to something kind of coarse here. I'm gonna do something like this. Created an issue. Oh, actually, it's okay. That works out well. That was 5 volts, so we can move it even. I did not realize that was 5 volts, so we can just move this even further if we want. Yeah. That might have created an issue here, so yeah. So I just kind of removed some stuff around here just to good space here. Not waste too much space. We might have to move stuff again, but okay. So where do we want to put our coin cells? Where do we want to put our lights? And this board shape right now doesn't matter. So it totally doesn't matter. We can do this whatever way we want. So looking at the 3D version of it, we've got these coin cells holders. They physically, right? The coin slides in the side there, and it the little springs on top push down on it. So they've got to be on the edge. Got to be on the edge. I have these physically here too. So you see, just to give an idea, right? These are these coin cell holders. They're just like that. They're just so they're just like that. They're little, oops, just metal prongs that pop in, and so you can see down here they use they use a pad on the surface as the other electrode. So this pad here is that is the bottom contact on the coin cell. And yeah, so it's got to be on the edge. So maybe we'll go back and we'll kind of start finagling this. So we have the USB stuff here. I kind of want to put the coin cells kind of on this edge if possible. Maybe I'll start with the big one. Let's see, does that work? Well, we'd have to move those resistors if we did that. Now, I'm not worried about the edge of the board. I can make the board bigger. That's fine. Is that good? What happened here? Oh no, we didn't. I think I forgot to select those when I did the original moving of this thing. That's no good. It wants to stay real far away from this thing. Probably because I don't know. I don't know what's going on. I don't know why that's having such a problem with that. Strange. Yeah, I don't know what there is. Oh. Weird. You know, I'm a little worried when I moved all this stuff too, that now everything's kind of a little off grid. So I'm a little bit misaligned now. Okay. Oh well. What's our dimensions looking at? I'm gonna click here and go. So we're 2 inches. Yeah. So if you want to change, by the way, from metric to imperial, you can hit the Q key. So see how it says millimeters there? Hit the Q key again, it says mils. So our limit is 100 millimeters by 100 millimeters. If I click the top left corner, millimeters, we're at 60. Yeah, so we got a lot of space if we want to use it. We don't necessarily want to use it, but if we do, we got it. So, okay, now it's fine with it, I guess. Now it's fine. It was throwing a weird error. I don't know why it was doing that. So I guess we could move this one here. Well, that one's not got enough space now. You want to have a kind of at the front edge. You want to be able to slide these off kind of with your finger. You want to kind of be able to slide in. There's a little groove here, right? There's a little groove. So when the battery's pushed in, it's uncovered on the top, and you can use your thumb to slide it off. So we kind of want the front edge of these batteries aligned with each other. It doesn't look like there's going to be a great way to do it, but we might be able to do something like this. Yeah, that might be good. I think that's going to work. The other thing I talked about is we could put one on the bottom. That's not great though, because these both have a giant pad on top. So you put one on the bottom and it kind of can create issues. So let's just, for now, set our grid 25. Balance it in the middle a little bit. That's pretty good. I think that's gonna work. Okay. So then our LEDs, we got all this real estate down here. We can put our LEDs down there if we want. So let's do that. So first of all, DS1 and DS2 isn't very useful to me. I don't really know right now where that is. So let's see which one's red and gray. So DS2 is red. So let's put the red one where we want it. DS2. So the red one is going to be it's not done charging yet. Put it near the edge. And this one will be the green. And right now, just for our benefit, let's label these things. DS2 was place. Change to top overlay. Place string. Okay. So that's just going to tell us. That's that way we know which LED to put in there. So, okay. And then, so, you know, when we're driving these LEDs, so the LEDs are going to be driven by something way up there. And we have these resistors to limit current through the LEDs. But if I'm placing resistors, they're kind of already sort of up here doing their own thing. So I'll probably want to try to keep them sort of in the same spot. The transistors, I might go near them, but yeah, those. The other thing to keep in mind is that if we do a stencil for this board, we don't necessarily want a stencil that includes these holes here. But if we may do a stencil for this, the perimeter of the stencil is going to be based on where we have surface mount pads that need to be stenciled. So if we do later want to do a stencil, it's nice to keep all the stencil stuff in one spot. I've seen students with their senior project, they'll have a big circuit board because there's weird stuff, and the surface mount stuff will be all over here, but then they'll have a little bit of surface mount stuff way off in the corner that didn't have to be there. It could have been anywhere else. But they put it all way off in the corner, and then they have to build this. They have to buy this stencil that's this huge amount of steel. When if they had just put it near the other stuff, they could have done something smaller than that. So, all right, now let's go back to let's build the circuit for this. So we have Q3, Q4, R24. Q3, Q4. Oh, it's already here. Okay, good. Okay, so I'm just kind of playing with these in a way that don't tangle too much. Looks okay. Look okay. Yeah. It's probably okay. That grid mess you up. Yeah, see, my grid's off. All right, when this happens sometimes, when your grid gets off from a part, when your parts were grid aligned and now they're not, sometimes what I like to do, if I had stuff that was all grid aligned and then I messed with it and now it's not, I'll do this. I will do edit, origin. So I'll do set, and you can set the oh jeez, we gotta set our grid finer for this. It's not gonna do it. Okay, so we just aligned the grid to that center of that pad, and then now I'm gonna go back, and now I'm gonna align my grid. I'm gonna set my 0 to something else. Okay, so now hopefully if I sort of readjusted my grid, that was not a good thing to do. Yeah, but now we're a little bit more back on a grid alignment here. Sneaking suspicion that I don't want to actually do this. I don't care about 5 volts. Okay. All right, let's route it up. Let's route it up. So grounds I don't care about. So the first thing I'm going to do, we got, let's start at the end. Not yet. We're going to move this one over. So, you know, the stuff that's like little mini. Now, these are traces that are carrying current to a LED. They will be carrying a fair amount of current here. So, well, not a fair amount. They'll be carrying a milliamp, but still, it's not a bad, you know, these, it does make sense maybe to have slightly fatter traces here. Probably not, actually. Probably not. But I don't think it hurts us yet. We can, it doesn't hurt us to do it. This signal. We'll go back to our 8 mil. You can go down to 6 mil with traces at pretty much any cheap fab, but it's not always a great idea to do it that way. Okay, so pre-flash has to get over here. 4.2 volt sig has to get over there. Sig. Whatever. You know what? We'll get it later. It's fine. Okay, let's. I think most of the, yeah, everything except for power and a couple of these signals. Oh no, we gotta route these buttons here. It's not gonna want to route these buttons if it's not gonna want to route these right now because our board is kind of small. So it doesn't like to route outside where we have defined board shape. But we do kind of need these signals. nice. Okay. And you'll notice as I'm doing this, I'm like really hesitant and thinking about things. Like I'm slow when I do this. I know I'm a lot slower than some people. Some people are really decisive. I'm not able to do that. I slow things down a bit. So now this is going to carry 10 milliamps of current. So possibly once we get out here like this, once we get out, we don't want to have long traces of this that are too skinny because it is going to be carrying a fair amount. Let's go to 24 with this. We'll route these on the bottom side later. Well, we'll route these on the bottom side now. So connected, so the tops are connected, the bottoms are connected, so both batteries should work fine. Now it's some of this other stuff. So, okay. So let's route these last signal traces here. So not worrying too much about the 5 volts and ground yet. Let's do the last signal traces. So we had 4V2 signal and a 3V signal. So these two signals we have to get down there. So we're going to start. We got to. So we're going to start. These are just signals, so they're not that special. And we're going to get away from the pad and then hit plus. And that's a massive roll of it. We need to change our default sizes on our file. So it just wants to put this thing in, it's huge. And so we hit tab, we're going to change this to whole size 13. I think you can go down to 12. And then diameter 27 is what I've typically liked in the past. 6 and 6 is 12. 25 I think works too bad. I know this is going to work, this size. So we're going to hit this. Where does this have to go? It's going to go to there. It's just going to go somewhere here. So we're going to get it near here, and then we're going to hit plus again. Make a connection, right? So now we've connected using the bottom layer and these holes. We've connected these two signals to one another. Now we need to do the same for 4.2V signal. There's plenty of space over here. Pop it over on the other side. Just have to go down here. Okay, those signals are routed. Was there another signal? I think there was one more. I had to get this, or if you get pre-flash, yeah, you get pre-flash. So did that. Oh, I think it was great line. Okay. Pre-flash is connected. Okay, now it's power. So the ground is the absolute last thing we're going to worry about, but let's get 5 volts. Let's try to route 5 volts on the top. So 5 volts on the top. Can do 5E0 here. Who else needs 5E0? You need 5E0. And you can get it from whatever. And who else needs it? So can we make a connection? Yeah, we can make a connection over from the pipe here. Let's punch it all the way through. Yeah. I don't like that. Weird, but better. Who else needs 5E0? Ah, you need 5E0. Oh, we also got a route principal thing too. Oh yeah, I remember you. Okay. Okay. How are we gonna get you 5 volts? You need 5E0 too. Well, we can get you 5 volts. And now we have 5E0 here. Around this way too. I'm not gonna connect this thing to the pipe. You don't usually want a fat trace like this. You don't normally want to directly connect a fat trace to a pad because you're going to have thermal issues. So if you have a big piece of metal connected to a pad, it's going to prevent you from, if you have touch soldering iron to the pad, it's going to act as like a heat sink. It's going to keep that heat, it's going to wick away that heat and prevent you from actually melting the solder. So like this either. Well, I didn't like how that was cutting close to that corner. So. Okay, now ground. So ground, for ground we can do, it's called a ground plane. And a ground plane is basically a plane of metal on one side or the other, where everywhere we don't use metal, we fill it in with metal of a certain signal. And it makes it so that we kind of cover everything with that signal. And it in the case of a ground plane minimizes the resistance path through ground. Anytime you have currents flowing through a wire, you have a small voltage drop. Grounds are especially important because grounds are the thing we always assume is 0 volts. It's our reference for everything. So if we had a circuit design and everywhere we had a ground, we actually had a slightly different voltage, that could create a huge number of problems. So the way we minimize that is by doing one giant piece of copper, very low resistance, everything is connected to this ground plane, and that's what we're going to do now. But before we do a ground plane, we want to really define the final dimensions of our board. So I'm going to go back and do the board dimension now. One more time. We kind of had it here, but I'm going to do it one more time. And we got a notch in there as well. So you might as well just do some weird metal there, mechanical 12, or what weird mechanical there. So one, design, redefine board shape, set our grid nice and coarse. Oh, what am I doing? Let's choose mechanical 12. I wasn't gonna actually do it right. Kind of a little wonky now. We might have to. You know what? Let's start over. Start from this side. How about that? Let's start over here. That nice rounded edge there. I'm actually going to snap to that board edge thing. Or close to it. Okay. Maybe it'll snap for us. I think it snapped. Okay, now there's a fair amount that I don't like about this. Oops. There's several things I don't like about this, but that's looking good though. Look at that. All right, looking great. It's looking good. Might move this a little bit. think that's kind of new in Altium. Automatically reroutes it by default. That's kind of nice. Okay, so we just got a little further away from the board edge. I don't like putting holes right up at the edge of the board. I also don't know why I did this like this. Oh. I mean, it's an art, not a science here, folks. But it's pretty good. Find some objects. Okay, let's take a peek again. Okay, yeah, so we've got this thing fairly well defined. It's looking pretty good. So now we can do a ground plane. So so I can do the ground plane right now, and that'll probably work out fine because I don't think I have anything else that needs to be routed on the bottom. Yeah, so let's just do that. Let's do the ground plane. Oops, am I good? Oh yeah, save. Place. Actually, I think there's a select your board edge and find some objects. Sometimes you can do well, it's been a while since I checked. Oh, wait. Oh yeah, it did. Okay, so it made this. So we selected all the mechanical 12 outline, and we said design. We said convert, create polygon from selected primitives. So if we go back into that, into the polygon fours menu, so we can change the layer on this, bottom layer. We can change the net to ground. Okay. So I just did report. Now, normally what you do is you can, the normal way you define a polygon pore is, whoa, that was weird. No, I don't like this at all. What the heck just happened? Solid. There we go. Okay. You just saw what I just did there. That was a way of converting the board outline to, yeah, that was the way of converting the board outline to pour. Problem is it got a little close to the edge here, so let me see if there's a way I can set a rule for that. But see what it did is it just covered this entire bottom layer with metal. So the whole bottom layer now is this metal. And so the nice thing is if we want to connect anything to ground, all we have to do is punch down to the bottom layer and we'll have a connection to ground. So yeah, but I gotta make sure it stays away from the outer edge there. So there's got to be some rules somewhere. So new clearance rule. Oh, let's do mechanical 12. Keep it so I keep away from mechanical 12. Minimum clearance will be, let's do 24 mil. Let's see if it actually did that. No, it did not. Okay, so this was an issue with the new Altium. This is why I have to do videos every single year. So there's something different than from what they had before. If we go to Polygon Manager, we can do this new polygon from, and we can just do board outline. So it was super easy. We could have just done that from the start. And sorry. So we're gonna want to do ground layer, ground bottom layer. That's fine. No. Yeah, remove islands. Let's remove next less than 10 mil. Looks good. All right. So I think it's good. Now the question is, did it actually do from the outside? Looks like it just went right up to the edge. It should be okay with, I guess it's okay if the plane goes to the board edge. I usually don't do that. Huh. Guess that's not any different than what I had before. Maybe. Okay, after some Googling, we should be able to create a rule. So there's rules in Altium that define how it does all this stuff. And so there should be board outline clearance. Here we go. Oh. Ah. Okay. Yeah, okay, so we have this default outline edge clearance. It should throw a fit after we do that. No. Maybe not. Well, I have no idea. Okay, now I did it. So we had a repour. So we had to set that rule. We had a repour. We're getting there. We're getting there. Another interesting thing I just realized, we actually don't need this. So if we do similar objects. Okay. Well, there is a way, if we define our board outline, and the other thing, one of the new things they've added is this, if we go to board shape, we can create primitives from board shape. So we can create from the board shape any mechanical layer we want. So if we didn't do this outline and then use that to make the board shape, we can take the board shape and use that to make the outline. I still would recommend not to do GKO, the keep out layer. So we've always done mechanical and then change the, some mechanical layer and then change the file name to GKO. The problem is there's a lot of parts that use keep out. The keep out defines a bunch of different things. Altium's using it as the board edge only is a little strange actually. So I'd still say do the mechanical layer, export it to a certain layer. But now we have a ground portion. Now we're going to go get these grounds in here. So all we have to do to get to place these grounds is we'll go to the top layer and we will just start dropping through holes. So connect to ground. hit the plus key, boom, hit escape. Back to the top layer. Well, now I guess these could all be connected here. But a lot of times with these ground connections, I like to do a bunch of them. So I don't care. I'll just go straight to. So I like the minus on the keypad because if you have a separate keypad on your thing, if you have a plus minus keypad, you can easily switch between layers. So I can click here, and then I want to make sure this doesn't interfere with the part. So I'm going to probably pop it down here to get it to the ground layer. So like I'm on the ground layer now. You can't see it, but I'm on the ground layer. So if I hit the minus key, it takes me back up to the top layer. Then I can hit escape and do another one. This key, escape, back up to the top layer. Round. This one I didn't leave myself a lot of room, so seems like it's fine though. Again, we're just popping everything down to the ground layer. Everything goes to ground. I'm going to give this a fatter connection to ground. This one too. Oh, you only wanted one side or the other. That's fine. So we don't want to have these connections to ground be too close to any pads. Actually, I don't like this. Much better. Good. We can fatten this up a little bit. Okay, we good? I think we're good. Let's find out. Okay. I don't see anything else. Let's do tools, design rule check. Solder mask sliver. It's probably on a USB connector, I'm guessing. Silk we don't care about. Solder mask we don't care about. Let's see where this is. What? At R12.1, resistor 12. Oh, okay. Yeah. All right. that it? Oh. Okay, so see what I just did here? These are thermal reliefs. So um, these are again, that if you're soldering to it, it prevents it from being impossible to cool down. There's a couple other things that we can do. So one thing is right now, these through holes are sort of like test points in that if you look in the 3D view. So right now, these are exposed metal, and that can be good if you're stabbing a probe to it to measure it. It's not always good if you don't want solder to bridge here. So one thing we can do is we can do right click, go find similar objects. And then same. Okay. So we're selecting all of these now, all of these. And if we go into tinting, we can do right. We can tint these. And so what that's going to do is now if we look at this, see now they're covered. So now they're covered. We can't get to them. But it brings up an interesting point. What if we wanted to test this board? What if we don't know how well this thing is working? We can't, we're not gonna be able to figure it out right now. So let's add some test points. So another thing that we can do, and we probably should have added this before, before we did all this stuff, but it's okay. We can go, one thing we'll do, because we already did the polygon board, we're gonna shelve it. So it makes it go away. And then we're gonna do some test points. So test points are a place where a pad specifically intended to measure a value of a signal at a certain location. It's good to put test points at key locations of interest around our circuit. So if we might be able to find one through the manufacturer's part search, but they're really just a hole. What's interesting? Well, none of them are. Yeah. We have, I believe we have one in the component manager though. In the WWU schematic library. Test point, yeah. Okay. Yep, test point. So right click to place test point. So we're just going to place a bunch. Anywhere we have something of interest that we want to measure. So, one thing is I'd like to measure 5-volt rail. I'd like to measure this voltage here. I'd like to measure this voltage here. I would like to measure, well, yeah, definitely want to measure across the battery. I would like to measure this output. I'd like to measure voltage produced by, I don't care about 3-volt sig, 4.2 sig. I want this voltage. Flash. Yep, want that. And just for fun, let's do here. Okay, so you might say, holy cow, John, you're putting a lot of stuff here. Yes. But, oh, and a ground. We always forget about ground. Yeah, you want a ground test point because that's going to be the other side of your probe when you're doing this probing. You're going to want a ground test point. So, okay, what did that do? So we got to go tools, annotation, annotate schematics quietly. So it's going to give us a bunch of these test points. And we can see kind of where these things need to go. So this one needs to go here-ish. Oh, wait, before I get crazy. Some objects. Now these are just test points, so they really shouldn't be carrying current. They're just for measuring voltages. You know what? Test points can be a little weird, and that's okay. There. Oh, that's our ground. Well, the ground can go anywhere, yeah. You usually want to put the ground somewhere, though, where it's like easy to get to. It's not going to interfere with stuff. So I'm going to put it on the edge down here. Sometimes I'll even change the name of it. TP11. And you don't have to populate these when you're building it. But if you run into an issue in doing it, it's really nice to have these. Where is this thing? What's it going to do? Let's go in here. Yes, I want to keep it away from that coin cell. Wait, are these the same thing, TP6, TP10? Oh, yeah. See, I'm getting near the end here. TP8, this is becoming just work. TP8 will be a fun one. Capacitor output. It looks like this was a little wonky too, so I should probably clean up my text while I can. Almost there. Trust me, it is. If you run into an issue with your board, especially when you're doing your senior project, if you run into an issue with your board, you are going to much prefer to have these test points than to not. So, yes, this is the other side of the battery. So when we're testing, we're going to probably want to have these near each other, sort of. There we go. Actually, yeah. So 2 battery ones. This is really good senior project practice because this is something that a lot of students don't do with their senior project well enough. They do it, but just, it's gonna be bad. Are we gonna get in there? I like to leave a little extra space. All right, let's see if it's gonna fit in there now. Nope. Okay, what else can I do here? Wait, is it? No. We will get it. We always get it eventually. The one spot. Sneak in there. It's gonna be tough to label. You know, there's only one test point near here, so. You normally don't want all these leads coming into your pad either. I should have connected it to another lead, to another trace instead of to another pad. So. Now, it's a situation where I may even want to delete that and just use the test point as the. Can we find one here? Now, see, the problem is it's having a mechanical issue. So it's not an electrical clearance. It's the. Oh, that does it. Yeah. So it's having the three. If you look right, it's this ring around it that was having an issue with, and that's not actually normally a problem because normally we can fix that. I mean, normally there's easy ways to fix that. So, okay, so now we're using the test point as the through hole connection. Don't want to tent that. What is this? 5 volts. Yeah, so 5 volts. You know, we got a ground there. Let's do the 5 volts near it, right? Okay. Altium is supposed to have a thing where each time you click it, it selects something new that you could possibly be clicking. And what issue did? Oh, it's too close to the LED. What's its beef? What's its beef now? What is this? What do I have a problem with? And sometimes it's just being stupid too. What on earth is its problem? So another thing is when you hover over it, it shows up in the top thing, component net1 violation, component clearance constraint to component on top layer and component on top layer. Sometimes it just needs to figure itself out. So I don't know. Oh no, it is still having an issue there. Okay, whatever. It's good now. Okay, so we want to re-pour that polygon. Polygon pours. Restore shelf poly. It's got to throw a fit. Polygon pours. Re-pour all. Now I'm going to go tool, design rule check one more time. There might be some issues now because we added all those test points. Nope, look at that, just solder mask. Cool. Okay, so we have a board that, assuming we did everything right, and a lot of this I didn't check, so don't trust my work, we should have a board that's good. So look at this thing, it's beautiful. All those test points, you're gonna love them. Okay, let's do some other stuff. So let's do some fun stuff. So one more thing that I want to do is we gotta add our name. So first of all, I'm gonna add, everything else I add is gonna be on the back because it's kind of busy here. It's a little busy here on top. So I'm gonna switch to the back. So if we want to work on the back, you know, you're working on the back side, all the text is flip and stuff like that. The easy thing to do if you're trying to add a bunch of stuff to the back is just do view flipboard. So now we're looking at the back side of the board. And sometimes it's good to select bottom layer while you're doing it. So now whatever we put on the back side of the board, we can look at it too. So whatever we put on the back side of the board will show up without the text being flipped now. So what do we want to put back here? Well, there's a lot of different options that we have. I'm going to show you how to put a picture. So if you have a picture that's black and white, and it's easy to get a black and white picture, just take the picture in Microsoft Paint, scale it to the size you want, or do a contrast thing, and then save it as a monochrome bitmap. Save it as a monochrome bitmap, and it'll be black and white. And what we can do is, if we're in here, we can do run script. And if we browse to, on the R drive in Altium, we have Pcb Logo Creator. Run convert script. All right, so this Pcb Logo Creator, it's going to ask us for a file we want. Now, I already saved, in the pictures folder, I saved this Viking, which is, I believe, yeah, 201 mils by 201 mils. And I want this thing to be, well, what layer? I want it to be the bottom overlay. Bottom. Actually, I'm going to do it on top, and I'll show you why. I'll do it on top for now. Oh, top overlay, top overlay. Where is it? Top overlay. So this is going to be the silk screen on top. And so it's 200 mils, so it's 1/5 of an inch if it were 1 mil per pixel. So I'm going to make the image size like that, 4 mils per pixel. I think the resolution is about 6 mils per pixel, but I don't want it to get too big. And then I'm going to click convert. So this should be 8/10 of an inch by 8/10 of an inch when we're done. Okay. So the first thing I do when I create a logo is I select all of it. And I right click it and I go unions, create union from selected objects. And the nice thing is then if I grab one of these, if I didn't do that, every time I clicked this and moved it, it would just take like one wire, because this thing is, it makes basically a bunch of lines. It creates the image with a bunch of lines. So now I have this object that I can move. So I can take this, copy it, click somewhere in the middle to align it, and then I can go over to my board. So I created a new PCB, and I can Control V. So I'm just Control C, Control V. I'm going to do it off the board here. So that just dropped it on my board. The problem is it's now dropped on it's a top silk screen. But I want to flip this to the bottom. So I can just, oh, come on now. Okay. So I want to flip this to the bottom. So I can select the whole thing and do Edit, Move, Flip Selection. And that will automatically mirror it and put it on the bottom layer. So now if I put this here, hit the 3 key, look at that. Just added a logo to my board. So that's good for now. I'm going to add some other stuff. I am going to place, oops. I'm going to place tag string. Oop, got the wrong layer here. I'm going to top overlay. Let's just do it. Let's do it direct on the bottom overlay. So place string. Now, if I hit the tab key, I can change some of this stuff. I want it to be a little bigger. Let's make it 100 mil. And instead of doing this, I'm going to do a true type font. So I like impact. True type font, 100 mil size, and I'm going to mirror it because I'm working directly on the bottom layer. I'm going to have it mirrored so it shows up right. I'm going to do name. I actually want it to be bigger. Name. Great. We're going to really grid align this thing right now. And then date. So name, date, and revision number. And then I'm going to place, staying on the same bottom overlay, I'm going to place a box. And it's a little too much of a box. Actually, no, here's what I'm going to do. So now, look at that. Now we got a little plate. Now this is something we can write on. So we can actually write on this, write our name, write the date, write the revision with a marker or something like that. And I think that's pretty good. So to me, that looks pretty good. Might as well finish it up. So you can add flare like that. Let's view. Let's flip board again. Let's do one last check in 3D. I didn't really look at front. So we're looking for like silk screen error, like a place where we can't see the writing on the silk screen. Anything like that. It all looks good. J1, J2. Yeah. Oh, this is technically backwards, I guess. This button is backwards. Shoot. Yeah, so this button, so this is the front of the button. So technically this battery's going in, but when this gets placed, it's a pad and 2 holes. So we just got to know to flip it around the other way. Should have noticed that sooner though. So it's going to be fine when we assemble it. Because look, it's like symmetrical, but It's a bad look for me. Okay, you know, I might want to add another thing. So switch it to top overlay. I kind of want to move this down. Place string. And then sometimes sometimes we can add a little note here. I'm going to change the font to something else. Flashing when under voltage, I can center it if I want. Pretty good. Maybe I want to change these, move these like here and here. Let's check. Looks good. It's good. Okay. Export this thing. File. Oh, save. So we had a new PCB when we did that logo creator. So, and now we're gonna go fabrication outputs. Files. So the paste I'm gonna export right now, but I'm not gonna actually send it to the fab. But we might if we want to do a stencil later. We don't need bottom paste. 12. Okay. This is what gave us issues last time. I think it was this use drilled slot command. I think that's what threw it off before. We didn't want to do that. Let's go to our project. Don't know exactly where it was stored. It's to skipping the top paste. We're not doing the top paste layer. Round hole, slot holes. Send to zip folder. Oh. All the drills look good. Look at that. Flashing under voltage, name date rev. All right, that's it. Assuming the circuit was correct, we did our project. Now here's the thing you want to do now. So this one, so the dimensions here, it passed at 61.9 and 56. We're gonna round this to 62 by 56. So if you're giving this to me and submitting this, you would do, change this file name to Lund 62 by 56 millimeters. You always round up. What color would I want this? I'll just make it blue. And 5 boards. 5 copies. Okay, so now this tells me that you want, your board is 62 by 56 millimeters. You want it to be blue, and you want 5 copies of that PCB. And then that would be what you would upload out to, you would upload this after checking this and making sure all the holes are good. You would upload this to Canvas through the assignment for the project, and your board would get sent off to Fab. So we'd then pay to send this to Fab, and in however many weeks it would be back to you, and it's time to assemble it. So, and as it looks right here, this would be pretty easy to assemble by hand. I don't think this would be that difficult to assemble by hand. But if we wanted to do a stencil, we'd go to stencil. We go to stencil, upload design. Now here, we want to upload the paste file. All right, I'm a little worried that there's only one pad here right now. This worries me. Is there only one pad? Actually, it doesn't have to be any. So maybe it was just, maybe I made this part, which had a wonky pad. All right. So top stencil. Okay. Wizard upload files. Wizard. I think the wizard upload files. Launch wizard. Oh, I thought I did. Said the same thing twice. Oh, generate essentials. Generate essentials, maybe. New user mode. I'm a dummy. Okay. So material type. I want so we can do polyamide, right? Ah. Huh. How much it costs? Let's do one stainless steel too. Frameless. Okay, well, so it looks like this, yeah, stainless steel is kind of expensive. Polyamide film, I might want a thicker film actually if I'm. Oh, shoot. Is there a downgrade? Shoot. All right. Got it. Let's do 5 now. Wait, 7.5. Cheapest we can do with a thick one. All right, 14 bucks. So 14 bucks for that stencil. It's kind of a big project, $14. And then we just enter a credit card and send it out. But again, this would be, we could actually modify this so it doesn't have that giant, so it doesn't have that giant pad. Let's see if we can do it from here. Tools, pad. Oh, so I had to click it and then select the right button and it made it go away. If I save it. Yeah. Okay, now I go back. It should be a little bit cheaper. I don't know, I messed it up. I'll get it later. All right, it's done. It's time for office hours.